Welcome to the lesson Autoflight Introduction. All of the functions provided by the Flight Guidance System, FGS, are collectively known as the Autoflight System. The primary functions of the FGS are Flight Director commands, autopilot control, thrust control, wind shear detection and recovery guidance, if fitted, pitch trim, and yaw damping. At the heart of the FGS is the Flight Guidance Computer, FGC. A second FGC may be fitted as a customer option. The pilot FGC selections are made through the Mode Control Panel, MCP, at the glare shield, a thrust rating panel on the right instrument panel, buttons on the control columns, and buttons on the thrust levers. A row of flight annunciators and FGS advisory annunciators indicate failures and statuses. For example, auto land status with the FGC and the yaw damper. Note that FGC2 and YD2 FGS advisories are only fitted to dual FGC aircraft. Autopilot, Flight Director, and Auto Throttle modes are indicated and confirmed at the Flight Mode Annunciator, FMA, at the top of each primary flight display, PFD. Power to the FGS is applied through the row of master switches on the avionics overhead panel. The yaw damp master switch controls the power supplies to the yaw damper circuit within the FGC and the actuator at the base of the rudder. The autopilot master switch controls the power supply to the FGC and enables the autopilot circuit within the FGC, the servos, clutches, and sensors around the aircraft. The avionics master switches control power to aircraft navigation and communication systems. These are required for the FGS to have full navigation capability. To ensure that the FGC finds no faults during its power-up test, the row of avionics master switches must be switched on from left to right. To depower the FGS, the row of avionics master switches must be switched off from right to left. Again, this will prevent any fault indications within the FGS. When power is applied to the FGS, a power-up test is performed, which takes approximately 45 seconds. When the test is in progress, no FGS functions are available. The following indications are present during the test. PFD, white dashes in the top left and right corners. FGC, advisories, FGC1 and YD1, FGC2 and YD2, if two FGCs are fitted. Flight annunciators, YD. PED, AF is shown in the N1 set windows. The result of the power-up test is given at the top right-hand corner of each PFD. Pass FGC 1 or 2. This indication is displayed for 2 seconds, indicating the test has been successful and that all functions of the FGS are operational. Moreover, the following indications are present: TO max in the top left corner of the PFD, TOGA max on the TRP, N1 set values and bugs in the PFD, and all fault indications are removed. Fail FGC 1 or 2. This indication, also displayed for 2 seconds, indicates that a soft fault was found during the test. This is not a complete failure of the FGS. However, one or more of the FGS functions are not available. Indication of the failed function is displayed on the instrument panels, for example, EL trim. In case of a hard fault, continual white dashes are visible in the top left and right corner of the PFD. No FGS functions are available and the following annunciators are visible. The FGS has a single flight director system which can be controlled by either pilot with the respective FD on-off switch located on the MCP. That FD, which is switched on first, is the master and uses on-side navigational system data such as VOR 1 or 2, ILS 1 or 2, LNAV 1 or 2, IRS 1 or 2, and ADC 1 or 2. It may be programmed using the mode buttons on the MCP to provide visual guidance dependent on the phase of flight. The commands are available as either a single queue, V-bar, or split queue. Crossbars dependent on customer option. Both presentations provide lateral and vertical guidance. The flight director vertical and lateral modes are selected at the MCP and enunciated in the Flight Mode Annunciator, FMA, at the top of each PFD. A green annunciator indicates an engaged mode, while a white annunciator indicates an armed mode. On initial selection on the ground, the flight director engages in takeoff, TO, as the basic vertical mode, providing a 7.5 degree pitch-up attitude for initial climb, and thereafter commands to maintain V2 plus 10 when all engines are operating. If the FGS senses an engine failure, takeoff mode commands pitch to maintain V2. It is a standard operating procedure to set V2 in the V-cell window at the MCP before takeoff. Track mode, TRK, is the basic lateral mode on ground. At 80 knots during takeoff roll, the actual aircraft track is stored and the FD commands this track once airborne. Track mode is also entered when performing a go-around or during wind shear recovery guidance. No mode changes can be made up to 350 feet radio altitude, neither vertical nor lateral. Selecting the flight director on in flight with autopilot off engages the vertical speed mode, VS, as the basic vertical mode and roll mode. Roll as the basic lateral mode. At the time of engagement, the VS on light at the MCP illuminates and the present vertical speed is displayed in the VS window above. The flight director commands the present vertical speed, which can be modified using the thumb wheel on the MCP. Upon entering the roll mode with more than 3 degrees bank, the flight director commands wings level. Thereafter, it commands the heading which was present when 3 degrees bank were passed. If the bank angle is less than 3 degrees, upon roll mode entry, the flight director commands the heading measured upon flight director engagement. The following lateral modes can be selected via the MCP. Heading Select provides lateral commands to fly the heading set on the rotary control. VOR LOC. VOR provides lateral commands to fly preset in or outbound radial as set on the master side, and LOC provides lateral commands to follow a localizer inbound course as set on the master side. Approach enables the localizer as the lateral and the glide slope that is tuned on the master side as the vertical mode. LNAV provides commands to follow the lateral track calculated by the master's flight management system. The following vertical modes can be selected using the MCP. Level Change provides pitch commands to maintain the indicated airspeed or Mach number as set in the VSEL window. Vertical Speed provides pitch commands to maintain vertical speed as set in the vertical speed window via the MCP thumb wheel. Altitude Hold provides pitch commands to maintain altitude based on the master's altimeter. Approach enables the glide slope as the vertical mode and the localizer as the lateral mode that is tuned on the master side. The synchronization sync button is only active when the autopilot is off and the flight director engaged in level change or vertical speed mode. Pressing the sync button, FD and the vertical mode in the FMA turn white, and the VSEL, respective the vertical speed value at the MCP, are set to the current values. They can now be altered by pilot's input through the control column. In a dual FGC variant, there are two separate autopilots, APs, which cannot be paralleled. Each AP follows the commands programmed through the MCP in the same way as the FD, by direct control of the ailerons, elevators, and depending on mode, the rudder. Power to the servos and clutches is controlled by the autopilot master switches on the overhead panel. Servos in the left-hand circuit are used with FGC1, FGC2 uses servos in the right-hand circuit. The single FGS variant accommodates a single autopilot